My name is Antoine van Oijen. I joined the University of Wollongong 6 months ago as a professor in the School of Chemistry, affiliated with IMRI as well. And what my big idea is that we want to develop tools to visualize how individual proteins interact with DNA. In particular, we want to see how DNA is copied. Inside your body, just before your cells divide, all your DNA has to be copied. And we are developing physical techniques, microscopes, we're building microscopes to make movies, if you wish, of how these individual proteins are going about their copying mechanisms. I've been working in this research field pretty much since I was working on my PhD, which is already 10 to 15 years ago. And over the last 10, 15 years ago, we've made an amazing amount of progress, not only our research group, but of course together with lots of other research groups around the world who are working on similar things. And I think if you look back and try to look forward how progress in the future will lead to newer therapies, I'm pretty hopeful that we'll make a dent. I've been blessed during my career to have experienced many highlights. I think the biggest highlights always are those moments during a bit of research where you actually make a new step towards understanding better how a molecule works. And those are always the most satisfying moments. And of course, when that later is followed by a fantastic publication in a high-impact scientific journal that describes that finding, that's of course an additional reward. But the real reward is being in the lab and discovering, seeing stuff for the first time. And this is something that we do with fantastically talented students and staff. This is a team effort, and that I think makes being a scientist in general a rewarding experience. So seeing is believing. So what we really try to do here is to build microscopes to directly observe, to directly visualize how individual proteins copy DNA molecules. So making those molecular movies, as it were, allows us to understand how these proteins work. And if we understand how these proteins work, we can think about what goes wrong when people develop disease, and then of course think about developing new drugs and new therapies.